Hello everyone, in this lecture I'll be taking another example on Rolle's theorem. So this is an example. Show that the function fx equal to 4 sine 2x has at least one horizontal tangent on the interval 0 and pi. Then find the value of x at which such a tangent exists. So the first thing we have to do is to see whether Rolle's theorem, the conditions of Rolle's theorem are satisfied or not. Let's plot this graph of fx equal to 4 sine 2x or y equal to 4 sine 2x on the xy plane. Okay, so let's take point 0. Since this is sine of 2x, so 2x can be, when is sine 0, when is sine of any angle 0? When 2x is equal to 0. So x is equal to 0, the value of sine of 2x is 0. Okay, when is the value of sine 1? The value of sine is 1 when 2x is equal to 90 degrees or pi by 2. Okay, so when 2x is equal to pi by 2, obviously x is equal to pi by 4. So let's plot another point of pi by 4. So at pi by 4, its value is 1. So the value of this function is 4. So it takes a value of 4 at this point. Okay. So when is it again 0? At obviously 180 degree. 180, that means it is when 2x is equal to pi or x is equal to pi by 2. So when x is equal to pi by 2, this value is again, the value of the sine function is 0. And the next value is at pi. Okay, when it is, so at pi again it is it is 0, and at 3 pi by 4 again the value will be, since it is in the third quadrant, so it will be minus 4. The value will reach minus 4. So we can now plot the value of the graph. Okay, so this is the value of the graph. This is minus 4 and it's 4. So now you see that this function is, obviously it's a continuous function. It is a continuous function. It is a continuous function. Okay, so number 2. Now we'll see whether it's differentiable or not. Obviously the function is differentiable. Okay. So if fx is equal to 4 sine of 2x, f dash x is equal to 8 cosine of 2x. Sine of 2x is cosine of 2x. Differential of 2x is 2. So 2 multiplied by 4 gives me 8. So it is 8 cos x. Okay. So the function is differentiable on the interval 0 and pi. So let's see the third condition. Third condition says f of 0, the first point, should be equal to f of pi. So what is f0 equal to? It is 4 sine of 0. That means it is equal to 4. Oh, sorry. 4 sine of 0 is 0. So 0 multiplied by 4 is 0. So f of 0 is equal to f of pi. As we see here, 0 and pi, the function is 0. So Rolle's theorem is satisfied. So now, since Rolle's theorem is satisfied, obviously there should exist a points where the differential of this function will be equal to 0. Okay, so let's see this. So if this is the case, then if we equate this f dash x is equal to 0, and we already know that f dash x is equal to 8 cosine of 2x. So at what point will So this means it's 0. So obviously 8 cannot be equal to 0. So it means that at cos of 2x will be 0. There will be existing 2 points. Okay. So there will be existing a point when 2x is 0. So when is cosine of 2x equal to 0? When 2x is equal to pi by 2. That means it's 90 degrees, and 3 pi by 2, which is 270 degrees. Okay. So at these 2 points, 2x, cosine of 2x will be equal to, because cos of pi by 2 is 0 and cos of 3 pi by 2 is equal to 0. So at these points, x is equal to pi by 4 or 3 pi by 4. So at these 2 points, the cosine of 2x will be having the value of 0. Okay. So let's see if pi by 4 and 3 pi by 4 exist in the domain that is given, that is 0 and pi. From this graph, we obviously see that 0, pi by 4 and 3 pi by 4 lie between 0 and pi. So obviously now we see this function has 2 horizontal tangents at x is equal to pi by 4 and 3 pi by 4. So this is a tangent at this point. At this point, dy by dx is equal to 0, and there is a horizontal tangent here. At this point also, dy by dx is equal to 0. Okay. So this is all for today's lecture. Thanks for watching.